So now we're going to move on to having a look at how we find the probability of making a type 2 error when we are dealing with the Poisson distribution. So it is believed that the number of red Skittles per pack is a constant mean rate of less than 4. So if we were to perform this hypothesis test, our H0 would have been that lambda equaled 4, and our H1 would have been that lambda was less than 4. It is decided that if there are less than 3 per pack, the claim is true. So that means that we have been told that we are going to reject H0 when x is less than 3. And then we're saying that it is later found that the true mean is 3.8. Find the probability of making a type 2 error. So remember, for a type 2 error, we're wanting H0 not to be true, and we are accepting H0. So you have to be careful when you're reading this to make sure that you are actually looking at the accept H0 region. So if we were going to reject H0 if x was less than 3, that means that we would accept H0 if x was greater than or equal to 3. We also know that the true mean is 3.8. So our H1 is actually 3.8. So we're trying to find the probability that x is greater than or equal to 3 using lambda is 3.8. So we're going to dist across to Poisson, PCD. If you've got one of the new calculators, then your lower is 3, your upper is a really big positive number, and your lambda is 3.8. And that gives us our probability of making a type 2 error, our beta, which is 0.731. Remember, if you have one of these old types of calculators, then you're going to have to change this to be 1 minus the probability that x is less than or equal to 2. Then your x would be 2, your lambda would be 3.8, and then you're doing 1 minus 0.26889667, which should again give you your 0.731. Moving on to the second example, it is believed that the number of errors per page on a first draft of a copy of a book is more than 3.8 errors. So our H0 is that lambda is 3.8, and our H1 would have been that lambda was more than 3.8. It is decided that if there is more than 6 errors, then the claim is correct. So again, our reject H0 region is when x is more than 6. That means that our accept H0 region is going to be when x is less than or equal to 6. And instead of using our H1 of lambda being greater than 3.8, we can see here it is found that the true mean number of errors per age in the first draft is 7. So H0 lambda is actually, H1, lambda is actually 7. So that means that again, in PCD, this time our lower is 0 because you can't have less than 0 errors. Our upper is 6, our lambda is 7, and that gives us our probability of making a type 2 error, our beta, which is 0.450 to 3 significant figures. And again, if you have one of these older types of calculator, your x would be 6, your lambda would be 7, and you end up with the same answer. On to the third example. The number of faulty matches in a box is believed to be 6. So this time we have a two-tail test. So lambda either is 6 or lambda is not 6 to begin with. It is decided that if 10 or more or less than 3 matches are faulty, then the statement is true. So again, we're being told the reject H0 region, which is that x is greater than or equal to 10 or x is less than 3. So if you struggle with this, you can draw yourself a quick number line so that you can then mark out where we're accepting, where we're rejecting. Remember, because this is Poisson, it is going to go on forever. So if it's greater than or equal to 10 or strictly less than 3, then we are going to be rejecting. So this part here is reject and this part here is reject. We're wanting the accept H0 region, which is going to be this one here. So we're going to accept H0 when 3 is less than or equal to x, which is less than or equal to 9. And the reason why I chose to write it this way is because if you have one of the new calculators, we can enter this in. So it is actually found that the number of faulty matches per box is 4. So our H1 is no longer lambda is not equal to 6. It is actually going to be that lambda is 4. So in our calculator, if you've got one of the new versions, our lower is 3, our upper is 9, and our lambda is 4. And that gives us our beta, which is 0.754 to 3 significant figures. Remember, if you have one of the older versions of the calculator, you're going to have to do the probability of x being less than or equal to 9 minus the probability of x being less than or equal to 2, and that should give you the same probability. So for all of these first 3 examples that we've looked at, we have been given the accept or reject region, and we've just been using that to find the probability of making a type 2 error. We're just quickly going to have a look at some examples of what we do if we're not given the region, but we are given the significance level of the hypothesis test that they are using. So to begin with, we've got Jerry wants to perform a hypothesis test at a 10% significance level to determine if the average rate that people run an amber light on a particular stretch of road is more than 9 per hour. So our H0 would have been that lambda is 9, and our H1 would have been that lambda was more than 9. And we're running this at a 10% significance level. So to begin with, because we're not actually given the accept or the reject region, we are going to have to find it. Now this is a one-tailed test, and we are looking for the value at which we first would reject H0, so we know that the rest of them are accept H0. Now because we're looking at a greater than, we know that if we had a number line, that we would be wanting our 10% to be at this top end. So we can either try and find where we have more than 90% down here or more than 10% up here. If you have a new calculator, then the 10% is just as easy to find as the 90%, but because people have a mixture of the types of calculator, I'm going to focus on the 90%. Now because this 10% has to be strictly 10% or less, we're looking for 90% or more. So, sorry, done that symbol the wrong way around. So 90% or more. So in our PCD, if you've got one of the newer calculators, we're going to put our lower as 0. For now, we are having our lambda as the one that's in our H0 when we're finding our region. So lambda is going to be 9. And we are going to try values until we end up with a percentage, which is 90% or more. So we'll start off with, let's say, 13. So the probability, and I'm going to write these down so I remember what I've tried. So the probability that x is less than or equal to 13 it was. is 0.926. So that's good, that's more than 90%. However, I need to know that that's the first value that gives me a probability of slightly more than 90%. So I'm going to try slightly smaller than that. So we'll try less than or equal to 12. So this time my upper is going to be 12. Remember, if you've got the old version of the calculator, the 13 and now the 12 is just going to be your x. And that gives me 0.876 to 3 significant figures, which means that the 13 less than or equal to 13 is what we call our accept H0 region. If you have one of the new versions of the calculator, you can double check that, because if less than or equal to 13 is going to be our accept H0 region, then that means 14, so 14 would be our lower, and more, so 99999 in the upper. That gives us a probability that is less than 10%, so we would be rejecting H0. So that means that greater than or equal to 14 is our reject H0 region, which is our critical region, which we have talked about previously. If, however, we had this one here, less than or equal to 12 being our accept H0, then that means greater than or equal to 13 would be our reject H0. You can see that that's more than 10%, and we're doing a 10% significance level, so actually that does not work. So it's the one that I've put in the box that is the actual one. Now we know the value, that means that we're going to be accepting H0. We can now do as we were before, which is, well, the actual mean, so we're changing our H1. The actual mean that we found was that lambda was equal to 11, and then we're finding the probability that we end up in this region. So 0 is our lower, 13 is our upper, and our actual value for lambda is 11. Oops, sorry, typed that in wrong. There we go. Which means that beta is 0.781. We're going to have a look at another one. This one's slightly harder this time. So we have a web server is visited on weekdays at a rate of 7 visits per minute. On a random 1 minute on Saturday, the web server recorded to see the number of visitors has increased. I'm going to change that to changed. I want it to be a two-tail one, so I'm going to change this to changed. A test at a 10% level of significance is performed. The true value is now 10 per hour. What is the probability of making a type 2 error? The reason why changed is a little bit harder is because we have to look at both ends. So last time, you can see when it was an increase, we were just wanting our 10% all on that side. This time, because it's two-tail and 10%, we're wanting 5% at this end, and we're wanting 5% at this end. So if we were performing this test, our H0 would be that lambda is 7. Our H1 would be that lambda is not equal to 7. And then we're looking at how we can end up with 5% on this side and 5% on this side. So, for the first one, we're going to try and find this value here, which means that I have at most 5% here. So let's try 2, see what that gives us. So probability of x being less than or equal to 2 gave me 0.0296, which is less than 5%. So I'm going to try a bigger number, so let's try 3. So probability of x being less than or equal to 3 gave me 0.0817651. So actually, this first value here is my critical value, the first value at which I would reject H0 on the lower part of our scale. So 2 is within this region and 3 is within our accept H0 region. So now we're going to look at the other end. So it's easier to do with the new calculator. If you've got the older calculator, you can either think of it as trying to find more than 95% this way, or you can do 1 minuses to find the less than 5% that way. So let's try greater than or equal to, let's try 9. So 9 would be our lower, 9 would be our upper. So the probability of x being greater than or equal to 9 gave us 0.271. That's quite far away. So let's try greater than or equal to 10. I need a bigger number. So let's try 10. So that gave me 0.170, still too big. Let's try 11, which gave me 0.0985. That's getting closer. Let's try 12. That gave me 0.0533, very close this time. I think it's going to be the next one. So greater than or equal to 13. There we go. That gave me 0.0270 to 3 significant figures. So again, this is my critical value at the top end, the first value at which I reject H0. So that means that 13 is the first value that's within that region, and 12 is going to be the last value within the accept H0 region. And because I've done it nicely on my number line here, I can then write down straight away that I am accepting H0 when 3 is less than or equal to x is less than or equal to 12. And then in the same way as we did before, we can replace our H1 with the actual constant average rate that we found, which was 10. So using that lambda is 10, we're trying to find the probability that we are within this region. So 3 is our lower, 12 is our upper, and our lambda this time is 10. Which gives us our beta of 0.789. So you can see that sometimes it can take quite a few tries to find the critical value, the first values at which you are rejecting H0. And then once you've identified your critical regions, the places where you are rejecting H0, the other part that we have is going to be our accept H0 region. So I would now like you to try the now you try questions. There are some where you are given the region and there are some where you are having to find the region. So just be careful to read it carefully to see if you have been given the significance level or if you are given the values which you are going to use to either accept or reject. Okay, so hopefully you paused the video and you gave the now you try questions a go. For this first one here, we were given that they think it's less than 5.5 errors per page. They've decided that if there's 3 or less errors, then that is going to be accepted. But what that's actually telling us is that is our reject H0 criteria. That's why I find it really helpful to write down what the H0 and the H1 would be, so that you don't get fooled by some of the language that they might use in the question. So if it's less than or equal to 3, we'd reject H0, which means that greater than 3 or greater than or equal to 4 would be our accept H0, which is what we're looking for. And when we put that into our calculator, now using our lambda of actually 5, we get 0.735 as our beta. For the second now you try question, they believe that now makes more errors than it did previously. So our H0 is that lambda is 2, our H1 is that lambda is more than 2. It is decided that the machine makes more than 4 errors, then it has increased. So that's our reject H0 region, strictly more than 4, which means our accept H0 region would be less than or equal to 4. Using the actual constant average rate of 7, and finding the probability of being less than or equal to 4, we end up with our beta of 0.173. For question 3, this time we're seeing if there is a change, because it just says that the average of 1.8, and then it says that if it's between 1 and 4 on the next spelling test, then they'll decide that it has not changed. And that's quite important. That's our accept H0 region, but because it doesn't say between 1 and 4 inclusively, then that means that we're not going to include those. So when we're actually putting it into our calculator, if you've got one of the new ones, we'll have 2 as our lower, 3 as our upper, and then we're using the actual mean of 4.5 per test, and that gives us a beta of 0.281. So for the next 2 questions, this is where we haven't been given the region and we have to find it, but you need to read these carefully. So here we've got bacteria are randomly distributed in a river at a rate of 5 per litre of water. A new factory opens and it is polluting the river with bacteria, so we're expecting that to increase then. He takes a sample of 0.5 litres of water, so we're going to have to, as we did in the Poisson hypothesis testing, half our constant average rate. So from 5, we're actually testing 2.5. So we're testing this at a 5% significance level. So it's one-tailed, so we want our 5% to be up at this top bit here. So at first I tested the probability of x being greater than or equal to 5. That gave me 0.109, which is bigger than 5%, so that's going to be in my accept region still. And then I tested greater than or equal to 6, which gave me 0.420, which is less than 5%. So that means that 6 is my critical value, and that is the first value in my critical region, in my reject H0 region. So that means that we're accepting H0 if x is less than or equal to 5. I can see that here on my little number line. And then we're told that the true average bacteria per litre is 6.3. But again, this is per litre. We tested 0.5 of a litre. So when we're using our true constant average rate now, we're actually going to be using 3.1. We know the accept H0 region is less than or equal to 5, and that gives us a beta of 0.906. For the last Now You Try question, this time we've got vehicles pass a particular point on a road at a rate of 51 per hour. After the introduction of a roundabout some distance away from the point, it is suggested that the number of vehicles passing it has changed. During a randomly selected 10-minute interval, the number of vehicles passing this point is counted to test if it has changed. The number of vehicles passing per hour is now 45. What is the probability of making a type 2 error? So you can see here now that we're given the information for an hour, but we're actually wanting to look at 10 minutes. So we're going to have to divide our 51 by 6 to go from an hour to 10 minutes. So that gives us 8.5 that we are using here in our H0. We're then we're not given the accept or reject region, and we're also not given the significance level. But if you remember, if we're not given the significance level, or in the case of finding type 1 or type 2 errors where we're going to accept or reject, we are going to use 5%. So because we're looking for a change, we know it's two-tail. So we're going to have to cut our 5% in half to have 2.5% at the bottom and 2.5% at the top. And you can see here that I was testing less than or equal to find where I ended up with less than 2.5%. And the first value that gave me that was 2. So 2 is my critical value at the bottom end, the first value in my critical region. And 3 then is going to be the first value at which I'm accepting H0. I then did the same at the top end. So you can see here that Sorry, I wrote those down incorrectly. That should have been 15 and 16, and then that means that this is 15, so this is going to change. Sorry about that. So 15 gave me a value that was more than 2.5%. 16 gave me a value that was less than 2.5%. So 15 is the last value in my accept H0 region, and 16 is going to be the first value, my critical value at this top end, the first value in my critical region at the top, my reject H0 region. So then we can see that we're accepting H0 between 3 and 15. So we put 3 in our lower, and that should be 15 in our upper. And then for the true mean, again, we are given 45 per hour. So we have to divide that by 6, which gives us 7.5. And then that gives us 0.9. 0.975. So it's really important that you do double check it. Like I did there, I put the wrong values in. So you need to make sure that you do double check before you find your actual probability of being in your accept H0 region. Thank you very much for listening.